event horizon actually was the entropy of a black hole. But there was one fatal flaw in Bekenstein's idea. If black holes have an entropy, they ought to have a temperature. And if they have a temperature, they ought to give off radiation. But how could they give off radiation if nothing can escape from a black hole? As it turned out, Bekenstein was basically correct, though in a manner far more surprising than he, or anyone else, had expected.
As he gradually lost the use of his hands, he had to start developing, carefully choosing research projects that could be tackled and solved through geometrical arguments that he could do pictorially in his head. And he developed a very powerful set of tools that nobody else really had. So in some sense, when you lose one set of tools, you may develop other tools, but the new tools are amenable to different kinds of problems than the old tools. And if you're the only master in the world of these new tools, that means certain kinds of problems you can solve and nobody else can.
My work up to 1973 was in general relativity, and was summarized in a book I wrote with George Ellis, called The Large-Scale Structure of Space-Time. Even then, it was difficult for me to write things down. So I tended to think in pictures and diagrams that I could visualize in my head.
I remember visiting Stephen and Jane at their home in Cambridge. After supper in the evening, when it was time for Stephen to go to bed, Jane insisted, and Stephen acquiesced, I guess this was standard, that Stephen make his way up. I've forgotten whether it was one flight of stairs or two flights of stairs alone, and this was a period when he could no longer walk. The way he got up the stairs was he grabbed hold of the pillars that support the banister and pulled himself up the stairs with the strength of his own arms, dragging himself up from the ground floor on up to the second story in a long, arduous effort. Jane explained that this was an important part of his physical therapy to maintain his coordination and strength as long as possible. At first, it was sort of heart-rending to watch what appeared to be the agony of pulling himself up the stairs until I understood. It's just part of life, pulling himself up the stairs like that.
General relativity is what is called a classical theory. It predicts a single definite path for each particle. But according to quantum mechanics, there is an element of chance or uncertainty. A particle does not have just a single path through space and time. Instead, there is an uncertainty principle, according to which both the exact position and velocity of a particle can never be known. I began investigating the effect quantum mechanics might have on particles near a black hole. I found that particles could escape from a black hole, that black holes are not completely black. At first I didn't believe it, but when I redid the calculations, I couldn't get the effect to go away.
I met Martin Rees, and he was shaking with excitement. And he said, have you heard? what Stephen has discovered. Everything is different. Everything is changed.
I was still unsure of my discovery, so I only told a few colleagues. But word soon spread. Roger Penrose phoned up on my birthday. He was very excited, and went on so long that my birthday dinner got quite cold. It was a great pity, because it was goose, which I'm very fond of.
To me, it's a miracle, because it's a complicated and messy calculation. We can now do these things very much better, and it's more transparent what happens. But out of this messy calculation, he showed that black holes aren't black with this quantum mechanical effect. There was a residual radiation. Stephen came to a meeting, and people were flabbergasted. And I remember someone getting up and saying, "You must be wrong, Stephen. I don't believe a word of it."
I once said that I was unhappy with the explanation given in terms of negative energy particles being created. But I feel this is part of the controversy of science. You must have the give and take. And I'm delighted to be able to be part of that. I mean, that's what makes it fun. You know, if you all sat down and said, "Oh, lovely," when you do have niggling questions in your minds, that's not doing a service to science. But I was not antagonistic to it in any way, except for that one time when I questioned.
I finally convinced myself that black holes radiate when I found a mechanism through which this could happen. According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating.